We're going to go ahead and start our next talk, our last talk for the evening here. And it is my pleasure to introduce Shaun McCullough, who is a SANS instructor. He teaches SEC 545, Cloud Security Architecture and Operations, and he's also a SANS author working on his brand new course, SEC 541, Cloud Security Monitoring and Threat Hunting. So with that, Shaun, I'm going to turn it over to you.
All right, thank you so much. Let me make sure I got my slides. All right, my slides are up. Thank you for joining me. Actually, that last talk was awesome. I'm so excited to go try out the Prowler integration. I love Prowler, and I do all AWS stuff nowadays, and so it's going to be really fun. I'm excited. Anyways, so my name is Shaun McCullough. I'm excited to be here. I have this thing I've been kind of thinking about over the last couple of years of me teaching the Security 545 class, which is all like operations architecture in the cloud. And I talk to students in the class, and sometimes they're on the security team or like the monitoring team, and they're being told, hey, you got to go in and try and figure out where, you know, an attacker is and what they're doing. And sometimes they're just given big piles of logs, and they're like, you go for it. And they don't have an understanding exactly how things are deployed or operating. And I just thinking about that. And as someone who I've spent, 25 years doing software development and then IT infrastructure and security, I love the fact that we can put them both together so nicely inside of the cloud. And it was so hard to hear about these people that have got to do threat hunting, and they don't have insight or they can't drive how the architecture is actually built. And so this talk is actually just taking a couple little things that I think are important to think about in your architecture for the cloud, and how threat hunting and also other kinds of, remediations and operations and scanning and kind of all those things can drive and become the benefit of a good architecture. I also like the idea that with in the cloud, I always try and figure out, can we improve security at the same time we're improving operational capability? Because it's, if you're running a security team and you've got we need this new piece of security equipment because we're getting hacked by whatever, and you got to go to the boss and say, I need $100,000 for this gigantic piece of equipment. That's a tough sell, right? If you ever done that, it can be really tough. What's a little bit easier is if you can say, hey, with some time and energy, we can speed up your widget creation at the same time as being secure. So I like to try and be able to put those things together if possible. So that is kind of a couple things that we'll talk about in the next little bit. Oh, Pat, how you like my slide? I'm pretty proud of it. It took me a while to find something really good. So we're going to have some of this kind of stuff all throughout the slides today. I'm sorry, that's just the way it is. So first of all, I've got to talk about what threat hunting is. Very official definition can be a proactive evaluation of the infrastructure, which means if you've got a security product that is monitoring and it says, oh, there's a piece of malware, you should go look at it. That's awesome. We got to do that. I don't consider that part of hunting. It's really saying, okay, where are my security products end, and where can the attacker still get in? Like we're assuming if we're a decent sized organization or we've got something that's important, we always try to say, hey, the attacker's probably in. Can you find them if they are? And that's really what threat hunting is, or hunting. We put the threat in the front because we want to say, don't just blindly look, but have a goal. Attackers are getting my other companies like this. I should go and see if I can detect. Sometimes threat hunting is just kind of digging through logs. And and it can be a lot of logs. And if we're moving into a cloud environment, they might be really different logs. So we got to kind of, if we can, from the architecture, make those logs more meaningful or more understandable, or maybe just less volume for detecting the right kind of things. That will certainly help. All right. So this is not by any stretch of the imagination all the hurdles for threat hunting. It's just the three that I wanted to talk about tonight. The first one is that it can be really hard in a regular environment. This is not just cloud, but it can be hard to figure out what's normal behavior and what's an attacker behavior. Imagine if you have an organization that allows remote desktop from admins from everywhere, and there's a lot of admins, and so you're remote desktop. It can be difficult if you're watching that to see if there's a bad guy or an actor or somebody that's doing remote desktop, because it just looks like normal in traffic. And so we got to try and figure out how to make normal and abnormal behavior, make that abnormal behavior really stand out. And so that's kind of that's what that first bullet is. The second one is there's a lot of data, especially in a cloud environment where we're maybe not used to the logs that we're looking at, or maybe we haven't invested in the tools that kind of manage and reduce the overbearingness of those logs. We might have too much data, but not enough actual knowledge about the environment. So that's the second one. Third one is our environments are designed to change very fast. We want to be able to spin things up and spin them down and have the new team come in and get their web apps out really quick. So that ever-changing environment and the loss of having the gatekeepers for, yeah, I know where all my servers are because I installed them and they're right there. I can point to them. You lose that in a cloud. And so the ever-changing environment makes it difficult. So I got 3 basic areas where I kind of think that organizations should focus in terms of trying to help architect their environment to support threat hunting and remediations and operations. And the first one is creating uniformity in your virtual machines and containers. Anything that you're going to build yourself that you have to manage in a cloud environment, you want to try and create this uniformity. So I've done this presentation before, and it's a longer one on just the subject, but we want to try and create a panel or a process where we can move things from our left-hand side to our right-hand side. Oh, I'm looking for the pen. I told there was a pen here. No, see, I don't think it's, I don't think I got to work. Yeah, all right, that's fine. So we're going from our left-hand side to our right-hand side. So imagine we work in an environment where we are going to automate the build process of our virtual machines. So starting on the left-hand side, maybe we said, we're going to start with like a Linux 2, CentOS 7 and 8, for whatever reason, we need both, Ubuntu, and then we're pulling something from a marketplace, right? And then what we want to do is we want to get our security team to develop a set of patches, configurations, hardening, all that kind of stuff. Like whatever it is the security team needs to do to make these images usable inside the environment, you have a set of scripts that go and build and do that. Then you move it to the yellow part, which is the developers. So the developers now are going to put their apps and whatever it is, the configurations on it, and that's what gets deployed. If you can build a way to automate this process and automate the testing, so that's very important. Did it actually install like you expected it to? Is there any problems? In our cloud environments, we have nice tools to be able to do this. And we can build this in a way so that those parts in the orange on the right-hand side, which is where we deploy our virtual machines from that place automatically. So we're elastic, we're spinning things up, spinning things down. We create a uniformity. We don't have dev teams or security teams SSHing into systems, installing them and patching them, doing all that kind of stuff. And so by creating this uniformity, not only do we get a benefit of significant elasticity, maybe better security, maybe better monitoring, our developers know what to start with. That's always really nice. Me as a developer and an IT person, I see both sides of it. And developers do like it when you say, hey, here's something that's going to work. So by doing this, we kind of create 3 different things. We can move from uniquely built virtual machines and containers to some kind of set of standards, a set of standards that are defined, that are documented, that are approved and known. Those standards don't ever change. Well, they do change. They change actually quite often, but they change when the team that manages says, yes, we're going to make a change. Just to back the slide up, think about the fact that if I automate this deployment and I automate this patching process, I don't ever have to do a full patch of all living systems. You could run this process and redeploy all your operating machines every week. So in a 7-day period, every one of your virtual machines is brand new and has been fully patched. Wouldn't that be awesome to not have to do that patch process? So by creating that uniformity, you can get that improved patch process. You also, if attackers gain access to one of these systems, it's a web server, it's sitting on the internet, there's a problem with it, they hack in. If they change the configuration, they install something new, they remove a log, they've got malware, they manipulate something, it's easier to detect. When the hunter gets onto that system, they can look at it, they can say, that doesn't match our standards. Ooh, actually what you could do is you could also use Amazon's scanning kind of capabilities, like the APIs and the things. to go and reach out and say, is there any differences? Oh, that makes it really easy. And not having kind of all these special case systems makes it easier for you to kind of detect that something's changed in this environment than if everything was kind of like everything's completely different. I also try and stress this idea that looking for a threat hunter can sometimes be looking for a needle in a haystack. And that's a very difficult, the thing to have to do. That's kind of the whole point of the needle in the haystack. But if your haystacks are configured and laid out and organized, that needle becomes easier to detect. So that's kind of the idea with that one. All right. So the next thing we can look at is with the jack-o'-lantern here is organize to reduce the blast radius. When we say blast radius, we're talking about if an attacker gets in, which let's just assume the attacker can get in. If the attacker can get in, then they can manipulate things around it. But can they get to the entire organization? If I've got a web server that's on the internet and it's got an app on there that's not managed, doesn't get patched or whatever, and the attacker gets in, can they get into that system and then pivot to the crown jewels of the organization? You want to make sure no. So what I always kind of stress is creating boundaries and establishing identified trust between those boundaries. Now, the boundaries could be anything. If you're using Amazon, you can use Amazon organizations to actually create a development organization. And in that development organization, you say, you can only spin up really tiny systems and you can't use Amazon's, ground station service, whatever the satellite thing is, which I don't even really understand. But, you can't use this expensive stuff because you're just developing web apps. So I can lock that down. If an attacker somehow gets into the development environment, they're significantly more difficult to jump over to the production system or your internal sensitive information. I always use marketing as kind of a good example because I always feel like, and this is a general statement, but your marketing data is designed to be published. And so it's unlikely for you to have really secret information in the marketing, right? Maybe you design it so that's the case. And so there maybe is less security requirements on there. Maybe you decide that I want a cloud, and in this cloud, I'm gonna put like my really expensive firewall service and all this. You may not have to do that for the marketing because you limit your blast radius. You can do this with organizations, you can do it with VPCs, you can do it with keys. I mean, there's lots of different ways, but the idea is create these accounts, these boundaries, identify your trust boundaries between them and monitor those trust boundaries. All right, what's this do for this? It allows us to build these organizations to group the risk. So that risk may be, access is kind of the boundary, or maybe there's a certain set of pipelines that are deploying for a marketing team or versus, whatever it is that maybe an event-driven architecture in the back end might be a different organization or group. And the data itself should be kind of separated out. And by creating those little limits, if an attacker is gaining access, they have a more limited view. You can put more of your security focus on the most vulnerable areas. And also your hunters can go in and focus on the high risks. And high risk is the data is really important, or, it's a ton of services that are on the internet that are getting hit from all sides, that kind of thing. So whatever high risk and high vulnerability is to you, you can create those kind of links and kind of group them together. All right. The last thing to look at is I always try to focus in a cloud environment, deploying your infrastructure through code or using infrastructure as code. And there's lots of different ways to describe it. But this idea that you create a pipeline, and the pipeline allows people to document the infrastructure. It goes through a set of automated checks. And on the other end is, Amazon infrastructure, web servers and networks and security groups and keys and all that kind of stuff. And by going through that kind of checklist, you can do a couple things. The first one, I really like the fact that you can have a defined description of what your architecture should look like. At one point in my career, I was working with blue teams, and we would go to a customer and we would say, hey, customer, what's your infrastructure look like? And they would be like, I'm not sure. So that happens. And it'd be like, it's been around for a while. We don't really know. So then you'd be like, okay, we'll scan it. And then we'll give you a diagram. And boy, they loved it. Like they didn't care about the report that said what was problem with it. They just liked the fact that they got this diagram because they weren't really sure what their infrastructure looked like. I like using infrastructure as code because I can implement documentation of what my infrastructure looks like. And I know that it's always up to date, assuming my pipeline's working. The next thing I can do is if I have security controls, I implement a automated test, automated implementation of those security controls in that pipeline. So if we have a requirement that says there's no SSH allowed to our production systems, we could do a check that says, do you have SSH turned on? And the answer can be no, and you're good to go, or it can be yes, and you stop it. Or normally you wouldn't just stop it, you would send a message, right? We get scared about automated remediations. But the whole point is I can codify those security policies. The next thing we can do is we can start automating. Well, in order to do this, we have to automate our tests. And that is performance tests, analysis tests. Does it really do what it's supposed to do? You can automate the test of code to see if you're got good code coverage. I mean, there's all these kind of tests. And then your final step in here on the right-hand side is deploying this architecture from a centralized location. And by doing that from a centralized location, you kind of can specify, this is the bottleneck that I want all my changes to come from. That's kind of where I use the point on the slides here. All right, what does this give us? Security controls, security policies that used to be in a notebook somewhere in someone's office that never gets updated. Anybody seen those? Has anybody written them before? That's always the worst. Those security controls can be codified. You can implement them so that they are scanned and they're required and there's an alert if someone tries to go against it. So that's really nice. It also goes back to my very first statement, which is that uniqueness of your infrastructure can be really reduced. If I'm doing a deployment pipeline where I've got systems that, I start on the left-hand side and I patch them and I deploy them and now they're in operations, I reduce my virtual machines or my Docker images. But boy, it'd be nice if I don't have a bunch of people creating security groups or keys or S3 buckets that might be open. So you kind of can reduce that unique infrastructure. And then you also have that gatekeeper for deployment. And this is awesome because if your CloudFormation or your Terraform or whatever it is doing all the deployments, it is much easier to see if I, Shaun, accidentally does a deployment, or if I spin up a server that I'm not supposed to, or if an attacker has gotten in and they have manipulated the environment. With somewhat CloudFormation, it doesn't work as well, but Terraform is really good about saying, hey, are there any changes? And going out and scanning and identifying, yeah, there's some changes here that could be okay, or we need to go investigate it. So that infrastructure's code also kind of has built-in checks. The other thing is that hunters can more easily identify changes that go outside proper channels. So that's kind of, those two can kind of be put kind of together. All right, so just some things to keep in mind as I kind of start wrapping up. Threat hunters need to be able to identify where it's hard to hunt. They can, after 6 weeks on the job, they can say, hey, this is just garbage logs. I just can't tell what's going on, or the infrastructure it looks messy, or there's problems. And that information should be given back to the architecture team, because then they can go say, all right, I'm going to focus on cleaning this up. Maybe it's improved deployments, or maybe even just better logging, better tagging, better identification of stuff. I mean, those threat hunters start getting to an idea of what's problematic. Threat hunters need to understand the architecture for them to do their job properly. They can't tell when something looks weird if they don't know what right looks like. So the threat hunters should be involved in that conversation about what the infrastructure looks like. If you're using infrastructure as code, they can go read it, hopefully, if you set it up properly. And over time, your threat hunters are going to start identifying things that they continuously do. And they can kind of feed that back and say, hey, look, if you do this, it'll automate 50% of my work. I really like this idea of, if there's an incident in like an Amazon or Azure, I have all the pieces available. I could automate data gathering and give it to the team that's going to do the investigation on Monday. And in order to do that, you have to have some understanding of the infrastructure. which means the architecture has to be defined pretty properly. So that is actually it for my talk. I don't know if there's any questions when we have time, but I appreciate your time. It's a really cool subject, and I'll hang out in the Slack afterwards if there's any questions.